Okay, welcome to the second lecture, the data acquisition lecture. Okay, most of you missed the class. Okay, this is a makeup class. All right. So when we talk about data acquisition, what do we mean? We mean simply how do we collect data, how we collect data, the process of collecting or obtaining the data that we need for analysis. Because when we talk about data science, the bedrock of everything that we're talking about is on data. So if data is the bedrock, how do we collect this data? Okay, so there are several ways that we can collect data for our analysis, and each of them depends on the project you want to run or the analysis you want to make, your target point where you are making the analysis. Okay, so the very first place is through survey and questionnaires. So in this approach, we collect data by posing questions to respondents, and those questions must be based on the problem definition. Okay, now you define your problem when you have actually spelled out the focus of your data analysis, and so depending on the goal you want to achieve, you know relevant questions to ask. Okay, if you are kind of doing a project work in a school, you must have perhaps read some literatures, and from the literatures must have defined some gaps, and then from the gaps you pose questions that you are going to ask your respondents in order to know whether you are, or rather in order to derive you, or rather to bring you to the path of your project goal. Okay, so you design your questions around the problem goal that you want to achieve. So this process is actually useful for gathering substantive and subjective information, opinions, and feedback from individuals. You can do this through interviewing individuals one by one, or you can just give out online forms for people to fill, paper survey in terms of if you are doing it in a physical manner. Okay, you reach out to persons, you give them the paper, and then they fill out the forms that you have already posed your questions in. Okay, the second approach is the observation method, and this approach is done by directly observing and recording of data from real world events or behaviors or processes. This approach is valuable for studying natural behaviors, interactions, and physical phenomena. Now, when you want to look at the behavior, the movement of people in a city, you must have to have a kind of mechanism to record or to observe people's behavior, people's movement. Okay, you want to look at traffic, okay, in a city. It is possible that you go to that city and then you stand out to watch how the traffic is per time. Okay, even though there are several ways that you can still collect information in that regard, especially by the use of sensors, but physical observation requires that you are there to study the natural behavior, the natural interaction of the things around that environment. Another way that you collect data is through experiments, and this is basically one of the things to use in scientific processes. Okay, so by documenting control procedures that are designed to test a hypothesis and gather data under specific conditions. This is common mostly in scientific research. You document the procedure when you, for instance, the picture you are seeing around is the picture of somebody, is picture of a scientist performing an experiment, and when you look at whatever that is inside this container, it must be weighed, or of course it must be weighed. The quantity of that thing must be measured, and then if you are mixing it with another thing and another chemical, you are measuring each and every one of them, and whatever quantity you mix with each other, you document it. And if you are to shake it for some minutes, you are documenting the time that you are shaking it. If you are leaving it for some hours, you are documenting the time. So all of those processes that you have documented have actually given you a data that you can use to make analysis. Okay, You can as well gather data from sensors that are mounted different or that are deployed at different places. Okay, for instance, you mounted sensors in a farm. Okay, you mounted sensors in a farm to report to you the humidity level or the temperature around your area. Okay, now when those sensors report to a gateway, data is collected and sent to cloud or sent to a database. So one of the acquisition method is through sensors. Now that sensor data, you can use it to actually analyze what is happening in your farm and what is not happening in your farm. Now you have web scraping. When you want to look at what exactly you can find in web pages, okay, you want to collect data from websites where APIs are not available or when specific information needs to be extracted. So you can as well use a software to gather this information. Okay, when this information are gathered, they can be stored in the database in Excel form, in CSV, or even in JSON format. And with those ones, in those structured approach, you can now access the data for analysis that you want to make. You have application programming interfaces where you can as well collect data from a different software or from a different application. You use your own application to interface with another application in order to collect data. For instance, when you are in an online platform, you want to access data from another service, you can collect such data using the interface that has been provided by that application, and that interface is called application programming interface. Okay, for instance, you have maybe hosted your model, your you have hosted your model online, and then you want to assess the behavior of the model. Then you can link your you can link up your website, or what is it called, maybe your mobile application, to access the model using an API. Okay, then there is the file based importing, and this is making use of data that are already in maybe JSON, Excel, or comma separated value notations. Okay, now when you want to make analysis, you simply import the data into your program, into your software, and then you begin to analyze the content of that data. So you can access data that have been already recorded in CSV format or Excel format, and so on and so forth. Okay, you can still access data that are stored in databases using some database management systems. And then you have the structured query language that is commonly used for querying such data for analysis. Okay, you can as well acquire data through data mining or social media data mining. Okay, analyzing and extracting information from social media platform, forums, and other online communities. This is what is known as social media mining. Okay, you can access data that have been carefully and officially logged. For instance, in a hospital where doctors perform shifts, whenever any doctor meets a patient, he takes up the file of that patient, and then when he's clocking the patient, when he's analyzing when he's clocking the patient, asking some information, you will just notice that the doctor is actually putting some things down. Okay, now those things that he has put down is called a log of what he has done. If he gave something, maybe if he prescribed a drug for the person, he writes the drug that he has prescribed. Okay, or the way that the patient is feeling at the moment that he gave the drug, he notes it in that log. Okay, the picture you are seeing here is actually a medical record. Okay, but this approach can be used in industries. for people working in a particular machine. The moment they finish working in that machine, they state the state of the machine and they log it before they leave. So when another person comes to work on that machine, the same person just using this approach will still work on that machine. So at any point in time you pick the log table of how the machine has been used over time, you will be able to look at the progress that has been made, and so you can run analysis on that logged data in order to maybe predict, is this equipment still okay, and so on and so forth. You can predict production, you can predict everything, but the bedrock of all these things is data. Okay, we can as well access satellite and sensor and remote sensing data. Okay, utilizing satellite imagery and remote sensing technologies to collect data about the earth surface. Okay, then there is this crowdsourcing. You gather a group of persons, you want to assess their opinion about a particular thing, then you start posing questions, and then you start noting people's contribution to that discussion. One of the main examples of this is focused group discussion. In other words, it is called focused group because the people that you have gathered to ask questions, or rather to have a discussion with, are people of the same clan. In parentheses, when I mean of the same clan, let's assume you want to ask farmers, sorry, you are carrying out research concerning farmers. Now, the people that are going to form your focus group members will be farmers only, and those farmers can as well come from a particular niche, maybe crop farmers, cereal farmers, and so on and so forth. So if your research is focused on getting information from cereal farmers, you wouldn't need to go and get somebody that is a cattle rearer to be in the group. It is no longer a focused group. So when you are now asking them questions, you are noting their questions, you are observing their behaviors, and all of those things, you are noting them down. That is data acquisition through crowdsourcing, what is known as focus group discussion. Okay, and one of the main problems of data acquisition is the problem of missing data, which we have discussed in part in the other lecture. Okay, now when we talk about missing data, it means that in the data that we have actually gathered, when we look at it very well, we notice that the data is not complete. Now, when you look at this particular image here, you discover that there is a gap in this. The chain did not continue the chain is no longer connecting with this one. Now the question is, what are we going to do, because there is a disconnect here? So there is a question here, what happened at this point? Are we going to be able to make a meaningful are we going to be able to make a meaningful decision from this data that is disjointed at this point in time? So this is the problem of missing value. So missing data refers to the absence or non-availability of values in a data set for certain observation or variables. Okay, so in any given data set, missing data can occur when there are no recorded or valid values for specific entries. Now look at two things that can connote a missing value. In the data that you have collected, you discover that one, there may be a column where data is not recorded. For instance, you post a questionnaire for people to fill, and at a point some persons discover that there are some private questions there, and they just decided not to answer you. Okay, now there will be nothing recorded in that manner. But there are also cases where something is recorded in the space, but it is not a valid value. Okay, now let's take for instance, you asked somebody his or her age, and the person decides that the person decides that this thing is a, let me say this thing is actually a private question. You don't have anything to do with my name, with my age. So instead of the person giving you a true value, because your required number, the person can just write 99 years. Whereas that the people that you are actually giving the questionnaire to fill are less than, their ages may be between 15 to 30 years. Now 99 years, you know that something is wrong in that value, okay? So that's actually a problem of what we may call outlier. Now it is actually a missing value because even though it's a number, but it's not a valid value at that position in time. So missing data can be as a result of any of the following: somebody that is decides not to respond to a question, then data entry error. Somebody wants to enter some data and then he misses the point where he should enter the data. Then sensor malfunction in cases when you are collecting data from a sensor, and then bad study design, and then data transformation, and then privacy concerns. For instance, the one that I just gave now as an example. Okay, so those are the things that result in a missing data or missing value. Now there are three types of missing values. Okay, number one is missing completely at random, then missing at random, and then missing not at random. Okay, now in the case of missing completely at random, in that case the missingness of the missing value is not related to the observed or unobserved data. It does not relate to it. Okay, the probability of missing data is the same for all observation. Okay, so what you have is not related to the observed data, observed variable. Okay, in the second one you talk about missing at random. So in this category, the missingness is related to the observed data but not to the missing data itself. Okay, it's related to the data that you are observing, okay, but not the missing data itself. Now the probability of missing data depends on other variables in the data set. Now the third one, missingness not at random. It says that in this case the missingness is related to the missing data itself. It is related to that data that is missing. Okay, now the probability of this missing data in this category is directly related to the unobserved values. Okay, now ways of dealing with missing data. If you have gathered your data for analysis and then you suddenly discover that there are data that are missing in this thing, how are you going to handle it? Because with the missing data, there is a disconnect in your data and you must have to deal with it before you proceed with the analysis. Okay, now the first approach is to delete. Maybe they want to delete the column. So it says this method removes rows or columns containing missing values. It's a straightforward approach, but this may lead to the loss of valuable information. Okay, now when you want to delete a row, you are deleting a complete record, and then when you want to delete a column, because you've found some missing values there, you may not be able to run analysis based on that variable that you are deleting. Okay, now the second way of dealing with it is by imputation. And when you look at the first diagram here, you see that this first box is having a blank space here with white. So when you want to fill it, you impute data into it. Actually, you don't know what to put into it, but there are ways you define, or there are ways to decide what to put into it. And then when you have put something into it, you go to the analysis phase and then the outcome. So in the case of imputation, the process replaces missing values with estimated or calculated values. Now see, the word is estimated or calculated values. So common methods of doing this, including using the mean, the median mode imputation method, or some more sophisticated techniques like regression imputation. Okay, now you calculate something and you put it there. perhaps some of those things may be based on the data you find around. For instance, if you are actually running analysis on student record and you suddenly discover that a student have refused to put his age, okay, or a student have put an age that we cannot take for that value, what will happen? It is possible for you to calculate the mean of the ages of other students and then use it to replace that value. For instance, you are dealing with undergraduates that their ages are between the ages of 18 and the 25, for instance, and then you suddenly see somebody with the age of 90. You now know that this is not going to be possible. Okay, so what are you going to do? You may take maybe the data between the age data above the person's data and the age data below the person's data and find the mean of the two and then put it there. Okay, that is imputation. Then the next one is data interpolation. So this method estimates missing values based on the values of neighboring data points and is especially useful for time series data. Okay, the kind of what I said, but this one is especially used for time series data. Now when you look at this, now you look at interpolation, you have something at this point and you have something at this point. Now you needed to note what is supposed to be at this point and you don't know it. So what you're going to do is maybe to take this one and take this one and use it to as maybe find the mean to get what is in between both of them. Okay, that is interpolation. Now I made mention of a student writing 99 years when, or rather 90 years when other persons are writing 20, 15 and so on and so forth. That particular incident is what is called outlier. Now outliers are data points that deviate significantly from the majority of the data points in a data set. Okay, the data points that deviates significantly. In other words, they are observations that lie an abnormal distance away from other values in a random sample for a population, or rather from a population. Okay, outliers can occur in various types of data and may have some substantial effect on the statistical analysis, leading to skewed results if not appropriately managed. Now, when we talk about skewness of data, it shows us whether that data is balanced or whether it is not balanced, whether it is heavy at one point or lesser at the other point. Okay, now when you look at this particular chart here, this graph here, you discover that every other data point is lying in this place within this range except this particular one here, and this is what is known as outlier. Okay, this is actually an example of an outlier. Okay, now the outliers impact on statistics. An outlier can heavily influence summary statistics such as the mean and the standard deviation, and can cause distortion like correlation. Distortion measures, or rather can also distort measures like correlation coefficients. Okay, how does this data point relate with this data point? The moment there is an outlier, if you don't deal with it, it's going to actually change the output of what you desire to get. Let's take, for instance, you have 10 students that you want them to write their ages, and then one of them, maybe majority of them are between the ages of 12 and 15, and then one of them, the age of that person is 90 years or even 150 years. Now if you add all of these things together to find the mean, you discover that the mean will be outrageously higher than the mean, and so the mean you will get will not be the correct mean because of what? The impact of outlier. Okay, now when we talk about variability, outliers contribute to increased variability in the data set and potentially affect the accuracy of statistical model, and that's another reason why we must deal with outliers. Okay, outliers in relation to identification methods, outliers can be identified through statistical methods like the z-score, the interquartile range, or visual inspection using plots such as box plots or scatter plots. Okay, sometimes you may not notice outliers when the data is still in the raw formats, but when you use visualization information, it is easier for you to spot outlier. So if we go back to this particular slide, you discover that if this data lies in a table, you may find it difficult to locate this particular outlier. But the moment we visualize the data using a visualization tool like matplotlib, we eventually and immediately see this particular outlier data point that is way outside of the scope of others. Okay, outliers are context dependent. So whether a data point is considered an outlier may depend on the context of the analysis and the nature of data. What this point is saying is that we don't consider something an outlier without considering the context. For instance, if I'm imagining students in secondary school, I've built a context, I've built a universe around that particular project, okay? And that universe is the secondary school scenario. And we know that these are teenagers mostly. Now, if I eventually get somebody that is 99 years and is still in secondary school, what does that tell us? That we're going to query it, we're going to look into it, we're going to research into it, okay? Okay. Now, if peradventure, that's what it means to be that outliers are context dependent, okay? So we are going to query it. Now, but if I'm running an experiment and I suddenly discover that some of these experiments, maybe I want to send sensor data to the internet and I'm observing the time it takes to collect the sensor information and send it to the internet, okay? Now, some of them may send in a matter of seconds, but then some may even take 1 hour to send. Now, that does not mean that that thing is an outlier. That particular thing is going to let me think and to go back to check what are the factors affecting the speed or the time response from data acquisition to sending to the internet. The point that it picks the sensor signal and the point it sends the same data to the internet. Okay. Now we may begin to look at the throughput. Okay, we may begin to look at the effects of the network that the system is based upon. Okay, now it does not mean it's an outlier, it just gives us an extra information that there are times that systems may change and what we intend as our output, or rather what we are looking at, may not be what we will get, and so that will call for more research on how to deal with such things. Okay, causes of outliers. Outliers may arise due to errors in data collection, measurement variability, or genuine extreme values in the population that is being studied. Okay, 3 things that may cause outlier in the data is this. One is error in data collection, measurement variability, or genuine extreme value in the population that is being studied. We look at data visualization. When you have organized your data, when you have cleaned your data, the next process in the data science life cycle, now you have prepared your data, the next process is to look at the data. Now, visualization is the representation of data in a graphical form or visual format so as to facilitate the understanding of the trends, to enhance analysis and the interpretation of patterns and trends. Okay, it involves the use of visual elements such as charts, graphs, maps, and dashboards to present information in a way that is easily comprehensible to both technical and non-technical audiences. Okay, so what is the goal of data visualization? What are the goals of data visualization? Number one is so as to be able to present complex data in a clear and understandable format. Now, when somebody gives you a table, you'll be like, what is all this? Where am I going to start? Okay, you don't understand the trend, you don't understand how the thing is. They gave you a time series data. The only thing is that you are seeing the years, but how to match it is what you don't really understand. And so with data visualization, complex data is presented in a clear and understandable manner. Two, it enables us to quickly discover patterns and relationship in a data. Okay, now it helps us to communicate data-driven insights to a broader audience. Okay, because at this point even the novice in that particular domain may find it easy to understand the trend that is shown, especially when you look at this data here, or rather this information here. You discover that from 1999, what we're looking at here is the industrial average, Dow Jones Industrial Average here. Now we look to see how the trend continue to drop between January and April 2009 until it got to the lowest peak, for instance, the lowest level, and then it began to rise again, and so on and so forth. And so we can say that within the period of 2009, April 2009 to January 2010, on the average, the Dow Jones Industrial Average appreciated, because what we are seeing here is that it continued to increase. Okay, now from January 2009 to April 2009 here, we can say that there was a depreciation in whatever variable that we plotted in this particular axis. Okay, now another goal of data visualization is to facilitate informed decision making based on what we have seen, based on the visualization information. Okay, so we have four goals of data visualization. Four main goals. Number one is to be able to present complex data in a clear and understandable manner, to be able to discover patterns, relationship and trends in a data in an easy way. Three, to be able to communicate data-driven insight to a broader audience, both technical and non-technical audience. Okay, then four, to facilitate informed decision making that is based on the visualization information that we have before us. Okay, now why are they important? Why is data visualization important? Data visualization provides a more intuitive understanding of complex data sets compared to raw data. Patterns, trends and relationships are made apparent. You see them immediately, like what we have here. The moment you look at this, you see that the pattern of this thing is immediately made apparent. But if you are looking at this data in a tabular format, you will not be able to find all these things the way it is now. Okay, visualization allows data scientists to explore and discover patterns, outliers and insights quickly. Like in the previous slides where I presented towards an outlier, the moment you look at that visualization of that, the moment you look at that data, you already see the outlier that is there. You don't need to look deeply before you can see it. So interactive visualization will enable dynamic exploration of data subsets. Visualization serve as a powerful means of communicating findings to non-technical stakeholders. Okay, they can convey complex insights in a digestible and engaging manner. For instance, I wasn't there when this thing was plotted out of any data, but whatever it is, one thing that I can tell you for sure is that there was a depreciation from this point to this point. Okay, and then from this point to that point, there was a significant appreciation, even though there were points of this depreciation, but they were not much. Okay, Excuse me. Okay. Data visualization aid decision-making process by presenting information in a format that is easy to interpret. So decision makers can quickly grasp key insights and key implications. Visual representation help to identify trends, anomalies, and outlier in a data, facilitating a deeper understanding of the underlying pattern and potential issues. Okay, data visualization enable the creation of compelling narratives around data. So they allow data scientists to tell a story that captures the audience attention and communicates the key takeaways effectively. Okay, thank you very much.